So hello friends, welcome back to my channel. So in today's video I am going to explain you it is 12th standard physics question paper Karnataka Award 2022. So let us continue. So in my last part I was explaining I was solving till 30 say fifth question. So that two questions or you can do, I think so. That is in the textbook only. So I'm going to 38th question. 38th question. They have asked here, with the help of a diagram, we have to derive the expression for torque. For the torque expression, we have to derive with a diagram also we have to write. On a rectangular loop placed in a uniform magnetic field. Okay. So first let us discuss the special case of the loop, that is, let us consider a rectangular loop, that is PQRS, rectangular loop, that is PQRS, its length is L and breadth as, let us take breadth as P, length as L and breadth as P. Suspended in a uniform magnetic field. It is suspended in a uniform magnetic field, that is P, uniform magnetic field P. So now let us write the diagram so that you will understand a little bit more. So here a mirror net drop like this, it will be yes. Then let us make it two part. Okay, this one is P, so this one is, let's take it as F here and here B. Here let us take it as L, length. This is the breadth, that is the length. Then the magnetic fields, here one, here one. Okay, I am just drawing it. It's not a correct diagram. A rough sketch and yet I am drawing. Okay, so after this, the next one is so we have got magnetic field in the uniform field, that is at the B. Now let A be the area of the loop. Let us take A, that is here, right? A, area of the loop. What are the things? A be the area of the loop, and I be the current. Let us take A as the area of the loop. I be the current in the loop. Now PQ is equal to RS is equal to PQ is equal to RS is equal to I. Okay. So let us take it as PQ R is yes is equal to I, that is the current. Now QS is equal to SP is equal to P, and area, as you know, area formula, that is equal to length into breadth. Okay, so according to the Fleming's left hand rule, the magnetic force across the side, that is PS and QR, are equal. So PS and QR magnetic force are equal, right? According to the Fleming's left hand rule. Now next, after this, the next we have to do is now torque T. So the side PQ, it experiences a normal inward force, that is F is equal to Pi, while the side RS, it experiences an equal normal outward force, outward side. So these two forces forms a torque Q, which we are writing here, T torque Q, force into arm of the couple, that is T is equal for B I or L also, you can say A sin theta. First one, T is equal to B into P sin theta or L sin theta. Now for a coil it turns. Next, for turns, T is equal to N. It is the number of turns the coil take, B L A sin theta. That is equation 2. Now after this, let us take a magnetic field, magnetic momentum of the current loop, that is T is equal to, it will become T is equal to MB sin theta. In the vector T is equal to, it will be M into P. This is the equation 4, this is the equation 3. So this is the answer for question number 38. Okay, question number 38 is done. Now moving on to our next question, that is question number 39. Okay, question number 39. Here they are asked to derive another expression for the magnitude of the magnetic field at a point on the axis of the current carrying solenoid. Hence we have to show that it is equivalent to a bar magnet. Okay, let us draw this one, right? Here O, then from here to here F into L. Okay, so after considering this solenoid, the length, let us take here length, here one length, and this is the another length, that will be 2L, right? So length is 2L, L is equal to length is 2L. Radius, let us take a, so let the number of turns per unit length of the solenoid. So let us consider a point, that is P, on the axis of the solenoid. This point, the outer, let us consider it as P. It is the axis under the solenoid. So the number of turns in this element, so the number of turns in this element is equal to N dx. Now the magnetic field at P, also distance we can take, and here also we can take it as A or. So now magnetic field of the element, right? So formula TB is equal to mu naught by 4 pi into 2 pi into n dx L a square. Okay, pi a square plus or minus x square 3 by 2 is the equation 1. Okay, now using this b, that is equal to mu naught by 4 pi, it will be equal to mu naught by 4 pi into 2 pi n l r square plus x square 3 by 2. Okay, after this, when the point p is at very large distance from o, when point p it is very large distance from o, then it will be dv is equal to mu naught by 4 pi 2 pi n la square by or cube into dx. We can make it as it is in large distance. Now integration if we do for this, b is equal to integration mu naught by 4 pi 2 pi n la square by or cube into dx is equal to mu naught 4 pi into 2 pi n la square by or cube dx. Here 4, let us take here plus 1, here also plus 1, here 4. Now if we do integration of this, we'll get the value that is so after this the value we get is okay. So after this we are done, b is equal to mu naught integration we have done 4 pi 2 pi n la square by r cube into x, here plus 1, 4 mu naught 4 pi 2 pi n la square by r cube l minus l. Okay, then it will be b is equal to mu naught pi 4 pi n la square by r cube. Equation 2 will get. After this, taking equation 2, now the magnetic moment of the solenoid is, the formula is m is equal to total number of turns into current into area of cross section. Okay, area of cross section. Okay, after this area of cross section, it will be m is equal to n into 2l into l into pi a square is equal to 2 pi n l a square l. So after taking equation 2, mu naught 2m by 4 pi into r cube p is equal to mu naught by 4 pi into 2m by r cube. This is the expression we'll get. So question number 39 is done. Now moving on to the next main, that is fifth one. In this party fifth main, first 40th question, they have asked here for showing the They have asked us here to show the current lags the voltage. We have to show that current lags the voltage by pi by 2 in an AC circuit containing a pure inductor. We have to draw the phasor diagram for it also. Now let us consider a inductor of pure inductance, that is L. Okay, pure inductance, inductor, and with a negligible internal resistance connected to an AC source. So the applied voltage at any instant to it is T. So therefore the value that is voltage will be V naught. Okay, V naught sine WT, equation 1. This WT will be, let us take in bracket. After this, the applied voltage varies with time. So it induces an EMF, that is Vt, the inductor which opposes the applied voltage. So therefore Vt is equal to minus L dL by dt. So first let us make a circuit here. Here. Okay. This is the L current. V is equal to V naught sine WT here. Now according to the Kirchhoff's loop rule, the voltage law also we can say V plus VL is equal to 0 we'll get according to Kirchhoff's law. Now this V minus L dl by dt, this is dl by dt, that is equal to 0. We can write it as V is equal to L dl by dt. dl is equal to V dt by L. So therefore it will be equal to, we'll get dl is equal to V naught sine WT, because V is here, by L dt we will take out. Okay. Now we have to put integration to this. Integration dl is equal to integration V naught sine WT by L, and dt also is attached here. So therefore, so L is equal to V naught by L, that is cos WT by W. So therefore L or I is equal to, I also you can say L naught, I can say I is equal to V naught by WL cos WT. Okay, I current wave again say that is equal to I is equal to V naught by WL sine pi by 2 WT. Now after this we will get I is equal to V naught by WL sine WT minus pi by 2, that is I is equal to I naught sine WT minus pi by 2. This is the equation 2. So therefore the peak value of the current we'll get here is, by this formula, after this formula, the peak value of the current we get is I naught is equal to V naught by WL is the peak value of the current we'll get. So by this, from this equation 1 and 2, it follows that the current lags behind the voltage by phase of pi by 2 in a pure inductor circuit. So therefore the phase relation V and I are, also we can draw the phase relation if you want. Here they have asked only is to tell. So the phase relation diagram also you want means you can draw. Now after this, let us move on. Question number 40 is done. Now moving on to our next question, that is question number 41. Here they have asked us to make the derive the lens maker's formula for a convex lens. For a convex lens, we have to make lens maker formula. 41. Okay, lens maker formula. So convex lens, let us put first convex lens here. Okay, after this, let us put some line from here. So let us take this as C, and here let us take this point here, this point as B, D, this one as A. After this, from this side, this one, let us take it as U. This one, first here, let us make the first point. So from here, let us take the light is going up. It is converging here. Okay, this point, let us make it as P. P, O. Okay. Now let us bring here. After that, here. Then we can make it here also. 2 points, I dash. Let us make it as 2 points. Then here V is there. First V, let us take here to here. Next V dash. Okay. So this is the diagram first we can write for this lens. Now considering this convex lens of R1. Okay, considering this lens. Now we are going to write the formula. Okay. So you can straightly write the formula, that is the refraction at the first surface number is ABC. It will be N2 by V minus Ny by U, that is equal to N2 minus N1 by R1, equation 1. Now Ny by V minus N2 by V dash is equal to N1 minus N2 by R2. Okay, this, let us take this equation 2. Now from equation 1 and 2, from equation 1 and 2, N2 by V dash minus N1 by U plus N1 by V minus N2 by V dash, that is equal to N2 minus N1 by R1 plus N2 minus N1 by minus R2. Now N1 by V minus N1 by U, that is equal to N2 minus N1 or 1 by R1 minus 1 by R2. So now after this, so N1 1 by V minus 1 by U we can take is equal to N2 minus N1. We are taking N1, it is common, so that's why we are taking here it out. So 1 by R1 minus 1 by R2, we are keeping it same. Now after taking this N1 out, now we can take 1 by V minus 1 by U, that is equal to N2 minus N1 by N1, we can bring it here, 1 by R1 minus 1 by R2. Okay, after this, okay, after this, next is 1 by v minus 1 by u, that is equal to n2 by n1 minus 1 by r1 minus 1 by r2. 1 by v minus 1 by u, that is equal to n21 minus 1 by 1 by r1 minus 1 by r2. This is the equation 3 we will get. So by this, after this, we can make it as 1 by f minus 1 by infinity, that is equal to n21 minus 1 by 1 by r1 minus 1 by r2. Or also we can make it as 1 by f is equal to n21 minus 1 by r1 minus 1 by r2, equation 4. Okay, this is the answer. Okay, so by this, question number 41 is done. The lens maker formula we have solved. Now the next question is question number 42. Here they have asked us to define photoelectric work function. They have asked us to define photoelectric work function and rate its 4 experimental observations. So first, work function, photoelectric work function we feel, right? So the minimum amount of energy required to remove electrons from the metal surface is called as photoelectric work function. Now the effects are 4 experimental observation of photoelectric effect are, first one I am writing here, that is photoelectric effect is it is instantaneous phenomenon. And the second one is, so photoelectric current is directly proportional to intensity of incident radiation. Next, third point or third experimental observation is kinetic energy of photoelectron is directly proportional to frequency of incident radiation. Now fourth is, so the minimum negative potential minimum negative potential, that is V naught, also you can say, given at anode A, for which photoelectric current becomes zero, for which photoelectric current becomes zero is called stopping potential. Or we can say it as V. Yes, also VB not. Yes, also you can say it as stopping potential. So 42 question is done. So 1 mark for this explain what is photoelectric work function, and for writing the 4 experimental observation of photoelectric effect you will get another 4 marks. So totally 5 marks you will get. Now 43 question, if you see here they have asked us to write the reflect. So what is rectifier, and with a suitable circuit diagram we have to explain the working of PN junction diode as a full wave rectifier. We have to draw the input and the output waveform. So this is available in your textbook also, I believe. You can check that, because if I go to draw here it will take me more time. So I will put the page number in the description. There you can see and understand, because here it will take means it is not possible to draw that big circuit here. So now next main 6 main for the 4th question. Now we are going to the numerical questions, where the numerical part begins. The questions which is in which you have to attend 3 questions, 5 marks each questions, you will get 15 questions. Now question number 44, if you come here, they are asked two small charged spheres having charges of 2 into 10 to the power minus 7 coulombs and 3 into 10 to the power minus 7 coulomb, and are placed at 3 centimeter apart in vacuum. We have to find the electrostatic force between them, and we have to find the new force when the distance between them is doubled. When we double the distance between them, what will be the new force they will get? First we'll write what are the things they are given. Given things, let us write. They are given that 1 by 4 pi v0 its formula. In that, the one part of the formula, its value is 9 into 10 to the power 9 nm square c minus 2. First, I think we should write the formula. So therefore f1 is equal to 1 by 4 pi e0 into q1 into q2 by aught 1 square. So this value they are given. Next, q1 they are given 2 into 10 to the power minus 7 coulomb. q2 they are given 3 into 10 to the power minus 7 coulomb. Next, R1 they are given 3 into 10 to the power minus 2 meter. This radius they are given R, and R2 is equal to 2, R1 is equal to 6 into 10 to the power minus 2 meter. R2 also if they may ask. So we are doubling the radius. As they have asked here, we find the new force when the distance between them is doubled. Distance radius is doubled. F1 is equal to 1 by 4 pi e0, that is 9 into 10 to the power 9 minus 2 into q1, that is 2 into 10 to the power minus 7 into 3 into 10 to the power minus 7, that is q2 by 3 into 10 to the power minus 2 whole square. Okay, after this, if we calculate the value, we'll get f1 is equal to farad is equal to 6 into 10 to the power minus 1 Newton. So F1 we wanted to find, we have found. Here what we want to find is F2 also, two new forces. So now F2 is equal to, again same formula, F2 is equal to 1 by 4 pi E0 into Q1 by Q2. Here R1, there R1 was there, here R2. So therefore F2 is equal to same value, 9 into 10 to the power 9 into 2 into 10 to the power minus 7 into 3 into 10 to the power minus 7 by, here it will be 6 into 10 to the power minus 2 whole square. So here F2 will be, after calculating this, the F2 value will be equal to 1.5 into 10 to the power minus 1 Newton. So F2 and F1, two forces that we have to find, they are asked in the question, we have done. So therefore question number, we have 44th question we have done. Now next numerical question, that is 45th question. Here they are asked, means they have given a charge of 8 meter coulomb is located at the origin. We have to calculate the work done in taking a small charge of minus 2 into 10 to the power minus 8 coulomb from a point of A, one point, that is 3 centimeter, 0, and at the point B, that is 0.04 centimeter 0, and point C also they are given by point C, that is 3 centimeter, 4 centimeter and 0. The things that they are given here, let us write it first. So first, Q is equal to 8 into 10 to the power minus 3 coulomb. Okay, charge. Q is charge. Now A, one point given 3 centimeter, 0, 0, that is equal to, we can say it as R1 is equal to 3 into 10 to the power minus 2 meter. Centimeter they are given here, meter we are converting. B is equal to 0, 4 centimeter, 0, that is equal to R2 is equal to 4 into 10 to the power minus 2 meter. Q they have given, that is minus 2 into 10 to the power minus 8 coulomb, or we can say it as minus 3 coulomb if we change. Now WAB, work done we have to find. So this is the things that they have given, all the things that they have given we have written here. Now after this, now we have to find the answer. Let us find it now. Formula to find the answer is, I think we can calculate here only. Let me write here the formula. Formula is VA is equal to VA is equal to 1 by 4 by 0, 1 by 4 by 0 into Q by R1. So 1 by 4 by 0 is value we have already done. So therefore that is equal to 9 into 10 to the power 9, okay, into VA into 8 into 10 to the power minus 3 by 3 into 10 to the power minus 2. So therefore VA is equal to 24 into 10 to the power 8 volt. Now VB also we have to find, VA and B, 2 points we have to find. So A we have done, VB is equal to same formula, 1 by 4 pi E0 into Q by R2 here. So therefore VB is equal to 1 by 4 pi E0, that is its value is 9 into 10 to the power 9 into Q is 8 into 10 to the power minus 2 by 4 into 10 to the power minus 2. So 9 to the 18. So VB is equal to 18 into 10 to the power 8 volt. So now the work done we have to find. So work done formula is WAB is equal to Q into VB minus VA. So WAB is equal to minus 8 into 10 to the power minus 8, 18 into 10 to the power minus 8 minus 24 into 10 to the power minus 8. That is, if we write in joules, WAB is equal to, it will be 48 joule is the answer for question number 45. So by this, question number 45 is done. Now question number 46, here they have asked, in the following circuit we have to find the current I. The circuit they have given here. In that we have to find which one is I. Okay. So let us find the answer now. Yes, so I think we should find the answer now. So the things that they are given here, let us write that first. They are given E1 is equal to 4 volt and this one. R1 is equal to 1 ohm. E by 2 or E2 is equal to 2 volt here they are given. R2 is equal to 1 ohm. R is equal to 7 ohm, capital R, this is capital R is equal to 7 ohm. And these are the things they are given, and the formula we have here to find the answer is, let us write that formula, that is R EQ, that is equal to R1 into R2 by R1 plus R2, that is R EQ is equal to 1 into 1 by 1 plus 1, that is equal to 1 by 2. So therefore R EQ is equal to 0.5 ohms. Now second formula, that is equal EEQ, we have to find. We have to find equivalent EMF of the condition combination. So therefore it is equal to E1 by R1 plus E2 by R2 into REQ. REQ we have got. So therefore EEQ is equal to E1 4 R11 plus 2 by 1 into 0.5. Okay. After this, if we calculate, we'll get EEQ is equal to 3 volt. Now the formula to find the current is I is equal to EEQ by REQ plus R. So therefore I is equal to EEQ is 3, 0.5 plus 7, that is equal to I is equal to 0.4 is the answer. So the current in this circuit is 0.4 ohm or volt, 4 ohms you can say. Now after this, if we come to our next question, that is question number 47 here. So question number 46 is done. After this, if we come to question number 47, here they are asked, a circular copper coil of mean radius 6.284 centimeter has 20 turns. Okay, if a current of 2A is passed through this coil, if a current of 2 ampere is passed through this coil, we have to find the magnitude of the magnetic field at its center, and also we have to find the magnetic dipole moment of this current coil. The thing they have given, let us write it now. They have given R radius is equal to 6.284 centimeter. In meter we have to convert, that is 6.284 into 10 to the power minus 2 meter, and n Newton turns they have given 20, and current ampere in the 2A, so this is also ampere we have to write. And next, this writing ampere and here also writing these values here joules, it is important, otherwise they may cut your marks, so be careful while writing this, whether it is ampere, joule or any other one. Next, B, that is the magnitude of magnetic field at the center, and magnetic dipole mu naught there given. So now formula is P naught is equal to mu naught Ni by 2, or P naught is equal to mu naught, that is 4 pi into 10 to the power minus 7 Hm minus 1 into N is 20 into I is 2 by 2 into 6 point radius 284 into 10 to the power minus 2, that is equal to, after this all calculating, we'll get P naught is equal to 40 into 10 to the power minus 5 torque. After this we have to also find the magnetic dipole of the moment, that is given. The formula is magnetic dipole. For finding the magnetic dipole is M is equal to Nia is equal to Ni pi r square, that is N is 20 into 2, A is 3.142, okay, and into 6.284. This is this formula, sorry, not this one, this formula, Ni pi value, and here the radius into 10 to the power minus 2 whole square. So M is equal to, you'll get 0.4963. So this is the magnetic dipole, and this is the magnitude of the magnetic field at this center. So question number 47 we have completed. Now moving on to our next question, that is question number, it is 48. Here we have to find, so here they are given a question that a ray of light passes through a, so a ray of light passes through an equilateral glass prism such that the refracted ray inside the prism is parallel to its base. So we have to calculate the two things they are given, that is angle of the deviation of the ray and the speed of the light ray inside the prism. Okay, these things we have to calculate. Now let us write the things that they are given. The things they are given is A 60 degree, N 1.5, and vacuum, light in the vacuum, speed of the light in the vacuum, C is equal to 3 into 10 to the power 8 meter per second. Okay, now first we have to find the angle of the deviation of the ray. So that formula is N is equal to sine A plus T by 2 by sine A by 2. Okay, this is the formula. Now N is 1.5 is equal to sine A is 60 degree plus T by 2 by 60 degree by 2 sine. Therefore it will be sine 60 degree plus T by 2, that is sine 30 degree will get. After this 1.5 is equal to sine 60 degree plus T by 2 by 0.5. Now 0.75 is equal to sine 60 plus T by 2. So therefore after this, if we take it out, we will get 60 plus T by 2 is equal to sine 0.75, that is equal to 48.6. So therefore D is equal to 37.2 degree. So the angle of the deviation of the ray is 37.2 degrees. Okay, this is the first year question. Now the another sub question that is B, that given is speed of light ray inside the prism. Now speed of light ray inside the prism. For that the formula is B phi is equal to C by A. This is the formula. Phi is equal to 3 into 10 to the power 8 by 1.5. So therefore by this we will get V into 2 into 10 to the power 8 meter per second is the answer we get. So therefore by this question number 48 is done. So let us move on to our next question, that is question number 49. In question number 49 they have asked us that two slits separated by 1 millimeter in Young's double slit experiment are illuminated by the violet light of the wavelength 400 nanometer. The interference or fringe are obtained on the screen placed at 1 meter from the slits. Have to find the fringe width if the violet light is replaced by the red light of the wavelength 700 nanometer, and also we have to find the percentage changed in the fringe width. What is the change of percentage in the fringe width? Also this also we have to find. Now what all things they are given, let us write. They are given D is equal to 1 into 10 to the power minus 3 diameter. Then wavelength 400 into 10 to the power minus 9 meter. Then they have given D is equal to 1 meter and P dash is equal to, we have to find wavelength 2, they are given 700 into 10 to the power. We are converting it into meter from nanometer. Now P minus P1 P2 is equal to into 100 is equal to, we have to find. So then the formula that we want to find this is, in first case that they are given, that fringe width is given, the formula of fringe width is given, is equal to wavelength d by d 400 into 10 to the power minus 9 into 1 by 1 into 10 to the power minus 3 is the thing. Then in the first case that they are given, in this we will get the answer as 400 into 10 to the power minus 6 millimeter. We have find the fringe. Now the violet light is replaced by the red light of the wavelength. Wavelength is 700 nanometer wavelength. In the second case, again the same formula we have to apply. That is, as we are finding wavelength, so it is same formula. The fringe width we are finding, so same fringe width formula we have to put. So 700 into 10 to the power minus 9 into, here d is also 1 into 10 to the power minus 3. Fringe width is equal to 700. This is second fringe width. Okay, not first one. 700 into 10 to the power minus 6. Now we have to find the percentage change in the given. That for this formula, percentage change. So B2 minus, first fringe width minus second fringe width by first fringe width into 100. That is equal to 700 into 10 to the power minus 6 minus 400 into 10 to the power minus 6 by 700 into 10 to the power 400 into 10 to the power minus 6 into 100, because percentage, right? So therefore it will be equal to, we'll get 100, it is percentage, right? So therefore second fringe width, so therefore the fringe width value will be B into 100, that is equal to 75% we'll get. So this is the answer for question number 49. So I believe that you understand question number 49. So let us move on to our next question, that is question number 50. So 49 is done. The last question of this physics, physics question paper 2022 Karnataka board. So the last question is, the normal activity of living carbon C14 containing matter is found to be about 15 decades per minute per gram of carbon. So a specimen found in an archaeological excavation has an activity of 1.5 decades per minute per gram of carbon matter. So we have to estimate the age of the specimen that they are given, and also the things that they are given. Let us write it first. Given things. The things that they are given is here. Or not. That is the decades. 15 decades per minute per gram. Or is 1.5 decades. Same. Per minute per gram. Okay. Then T is equal to, we have to find time. Okay, 5730 years. This is big multiplication you have to do. That is 5730 years into 365 days into 24 hours into 60 minutes. That is equal to 3.01 into 10 to the power 9 minutes, or you can also make it into seconds also. Then now if we put the formula, so decay constant of C14 is wavelength is equal to 0.693 by T. 0.693 by T. If we take, so therefore it is 1.2. T value is 5730, right? That is, we'll get 1.2 into 10 to the power minus 4 per year. Then from the law of radioactive, we have that R is equal to R not E. So EU is equal to R naught by R, that is equal to 15 by 1.5, that is equal to 10. So therefore delta T is equal to log E10 is equal to 2.3031 log 10 by 10, that is equal to 2.303. So therefore So therefore, after this, the final efficiency T is equal to 2.303 by Vln, that is equal to 2.303 by 1.21 into 10 to the power minus 4. So therefore T is equal to 1.9033 into 10 to the power 4 years. Is the answer for question number 50. So therefore the questions are done. So therefore 12th standard English, 12th standard physics question paper 2022 Karnataka board. So all the question is done. So okay friends, in my next video some other question. Till then take care. Have a nice day. Bye my dear friends.